Okay, here's a problem that came across my desk. Let's continue to factor trinomials where a is not 1, this time with the quadratic formula, which is x equals the opposite of b plus or minus the root of the discriminant, b squared minus 4ac, all over 2a. So write that every time you use it, and you'll always remember it. So we're going to start with the discriminant, which is b squared minus 4ac. Okay, b is 9, so 9 squared is 81. Negative 4 times a, which is 2, is negative 8, times c, which is 9, is negative 72. Okay, let me double check that. Yep, okay. And 81 minus 72 is 9. I'm going to circle that. That is not my answer. That is not a solution. That is my discriminant. And because this discriminant is a perfect square, it tells me that this trinomial is factorable, which is good news. I don't want to waste my time trying to factor something that is not factorable, or in other words, prime. And so I'm going to go ahead and continue with the rest of the quadratic formula. So I've got the opposite of b plus or minus the root of the discriminant, right? The root of 9 is both positive 3 and negative 3. And all over 2 times a, which is 4. Okay, and so now I can split this into negative 9 over 4 plus or minus 3 over 4. And that's going to, going off the edge there. Let me go an easier route with that. That's going to confuse a lot of people. So negative 9 minus 3 is negative 12. And negative 9 plus 3, is this on camera? Yeah. Negative 9 plus 3 is negative 6. And this is going to reduce, these are solutions right now, although we're not solving. These are zeros. Talk about that in the future. This one's going to reduce to negative 3, and this one's going to reduce to negative 3 over 2. Now, how is this factoring, right? The quadratic formula is for solving quadratics, not factoring them, right? Well, remember, this whole thing starts with x equals, right? So this is x equals negative 3, and x equals negative 3 over 2. So let me write it that way. X equals negative 3, and x equals negative 3 over 2. And if I move everything to the left, I'll show my steps here. On this one, I'm going to add 3 to both sides. We'll just do them one at a time because they're pretty different. That's going to cancel that out. And that's going to give me x plus 3 equals 0. And that's one of my factors right there. Right? The whole zero product property in reverse. And this one, I'm going to multiply both sides by 2 to cancel out the denominator here. I'm just moving everything to the left. And so this is going to, I'll put a dividing line there. This is going to give me 2x equals negative 3. And then I will add 3 to both sides. Again, just moving everything to the left equal to 0. And that's going to give me 2x. Am I still on camera? 2x plus 3 equals 0. And that's my other factor. Yeah. So by using the solutions with the zero product property in reverse, I've got my factored form. X plus 3 times 2x plus 3 in no particular order. Okay? And we can check that. First, x times 2x makes 2x squared. Outside product 3x, inside product 6x makes 9x. Last product, 9. Okay, so there's a lot of work on this page, but sometimes the factoring just isn't coming to your head. You can always use the quadratic formula. And the great thing here is you start out with the discriminant so you know that you're not wasting your time on something that's not factorable. And then, of course, we can get into ones that aren't factorable. You can still do this even when it's not factorable. So you can use the quadratic formula to solve or factor every trinomial, not just the easy ones. If you have a math problem that you would like me to demonstrate, put it in the comments and I will. Hope that helps.